Hi everyone! In the previous video, we used 4 comprehensions to simplify the composition of IOs. Now the code of user creation service is quite readable. But we aren't done yet, because we only implemented the happy path when all the inputs are correct. So in this video, we'll focus on offering a better user experience when something goes wrong. First, we'll add error messages to explain to the user what is the issue, and then we'll implement some retry logic so that users can correct their own mistakes. First, let's go to the file io.scala. You should see the method onError toward the middle of the file. Here. So this method runs the current action, and if it succeeds, then onError doesn't do anything. However, if the current action fails, onError executes a cleanup function and then rethrows the original error, exactly like what we have done in the imperative implementation. Cool, so let's pause the video and let's implement onError, and as usual, you will find a few tests in iotest.scala. Don't forget to enable them. Okay, so let's enable the tests first. Here, yes, there is 2 of them. And let's go back to the implementation. So what we want to do is to create a new IO, so we'll use the IO constructor. We need to run the current IO, so we need to do an unsafe run, but we know that it can potentially fail, which means that we need to catch the exception because we want to differentiate based on a success or a failure. So let's say we use try and then an exhaustive pattern match. Then, as often, if it's a success, we just keep the result, we'll return it like this. Now the interesting part is, if it is an exception, we're going to call the cleanup function like this, and then we want to rethrow the original error. So we'll say throw exception, like this. So let's run the test. Oh, I actually run the wrong test suite, so I want to run IO test. So let's do this. So the test failed. So one passes, the other one failed. And what does it say? Okay. So what does this test do? It creates a variable counter, creates an exception, and what we do is that the first IO fails with an exception, so the first IO throws an exception, and here we verify that onError is supposed to increment the counter. So we verify that onError is lazy, meaning that nothing has been evaluated, so this we did it well. Then we verify that once we run the action, counter should be equal to 1, meaning that the callback function, the cleanup function, should have been executed. But it seems that at the moment it's not executed, so let's go back to the code. Yes, so what happened here is that cleanup here, if you see, it returns an IO of other, but because we don't run it, or we don't compose it with another IO, so we don't do like a flat map or a map, we just create an IO, but an IO in itself is just a description of an action. It doesn't do anything. We either need to combine it with another action that we'll eventually run, or we need to run it right now. So this is what is missing here. We forgot to run this cleanup function. So let's do this. And now the test pass. Cool, so now let's go back to user creation service. And the goal now, we're going to update read date of birth and read subscribe to mailing list so that they will publish an error message in case something goes wrong. So if you open the test file associated to user creation service, you will see that there are a few commented lines. So can you just remove this? So at the moment, the output list of read date failure in this case will only output the question, but it didn't output this error message. So now we want to change the test so that we verify that we do actually output the right error message. So you need to update also this line here. And now if we rerun this test, so if we rerun user creation service, it should fail because we haven't implemented this error handling logic. So now can you please update read date of birth and read subscribe to mailing list so that the proper error messages are produced. and please try to use onError to do that. Okay, so for read date of birth, what do we need to output in case something goes wrong? It's this sentence. So what we want to do is say, in case something happens in the parse date of birth, we want to use onError that will give us access to an exception. And what we're going to do in this case, we're going to write a line that will say, actually I will need triple question mark to avoid escaping. Yeah. So here what we say, actually we don't care about the exception, we just say, in case an error occurs, please write this line to the console. Let's run the test. Okay, so this test passed, and we're going to use exactly the same principle here. In case an error occurs in the parsing logic, we want to write the following error message: incorrect format enters Y for yes or N for no. So let's use triple question marks, triple quotes, and let's run this. Yes, all good. So it's quite nice and quite expressive, this, the way we can express what to do in case an error happens. Now, you might find it a bit annoying to have this kind of callback within the for loop. So there is another refactoring we could do, is we could extract the error message, we could extract the action we want to do in case an error occurs outside of for comprehension. So we could say, for example, print error. So print error is the action we want to do in case something goes wrong. And then we can say here, in case something goes wrong, just execute print error. Let's run it. So everything is good. So what's quite nice is because I/O are completely lazy, we can extract or inline all the actions we want. The refactoring is completely safe. Here, when we define print error, we just describe some things, and when it will execute, will print to the command line. But as long as it's not executed, like nothing happened. So that's quite convenient. Cool, so now the only thing missing is the retry logic for read user. So let's execute this version of user creation service just to see what is going on. So at the moment it asks for my name, so let's say Julian, my date of birth. Okay, and let's say I make a mistake while I enter the subscription flag. I say like never. Boom, it fails. So at the moment we do get a decent error message. It says incorrect format, enter Y for yes or N for no, but we don't have the opportunity to correct our own mistake. So what we can do is that let's go to io.scala and you will see the method retry. So retry takes an int which represents how many attempts we have to evaluate the action. Meaning that if the action is a success, then we are good, we don't retry it. But if there is an error, we check if we have any attempts remaining. If we do, we retry the operation. Note that max attempt, like similar to the imperative version, must always be greater than 0. Otherwise, retry should fail the I/O. Because it doesn't make any sense to call retry with 0 or negative max attempt. So cool, so now it's your turn to implement retry, and don't forget to enable the test in iotest.scala. Okay, so let's enable the test first. So we have, I think, 3 tests for retry. 1, 2, 3. And so let's try to implement it. So first we use the I/O constructor, and we need to deal with max attempt being equal or lower than 0. So again, we can use require and say if max attempt must be greater than 0, otherwise we want to throw an exception. Max attempt must be greater than 0. Cool. Then next step, we want to evaluate the current action. So we want to call unsafe run. But we know that this can fail, so again, we're going to wrap this code in a try to handle the errors properly. This will give us back a failure and a success. If it's a success, we're happy, we keep it. If it's a failure, we want to retry it. So we're going to call retry recursively with a max attempt equal to max attempt minus 1. So here it's an IO of A, so we need to run it, otherwise nothing will happen. Okay? And we don't care about the exception. So let's run this test. So let's run iotest.scala. Cool, so almost all tests pass except the last one. And here, what does it do? Oh yeah, so it verifies which error message was printed, which exception was thrown. So in this case, we see that we expected to see a boom. This is the custom error that we are triggering here. But we got this requirement fail, max attempt must be greater than 0. This is exactly what we had before in the imperative version. We forgot to handle the case, the end of the recursion. When max attempt is equal to 1, we don't want to recurse anymore. We want to just throw the exception. So in this case, we want to say throw this thing. So this is an exception. We want to throw it. There is no point to keep retrying because we know we have exhausted all the possibilities. Cool, so let's run the test. They all pass. Awesome. So let's go back to user creation service. And now the goal is going to update reducer to add the retry logic to it. So the goal is to make the two questions that can fail, the date of birth question and the mailing list question, to give like up to 3 attempts to the user to enter a valid response. So please pause the video and add the retry logic. Okay, so now it's fairly straightforward. We just need to call retry on the two questions. So we just say max attempt 3 and same here, retry with max attempt 3. These are the only two questions that we want to retry, and that's it. Cool, so let's run the test to check that we haven't broken anything. Yes, all good, which makes sense because by adding some retry, by adding some additional attempts to answer the answer, we are just being more permissive. So if the test passed before, they should pass if we allow for some mistakes. Now, if we want to test this a bit better, at the bottom of user creation service test, I added a property-based test that actually generate random numbers of failures and verify that if the number of failures is bigger than what we allow, then it throws an exception, or at least it fails. So let's enable this test and verify it. So as you can see here, what it does is that it generates a name. So this name is the name of the user. It generates a list of invalid dates. So this list may be like, there might be 2 elements, 5 elements, 10 elements, 0. And then it generates a valid date. And so when we construct all the date input, we put like a list of invalid date followed by a valid one. And then, if you see at the end, what we verify is that if the size of if the number of invalid date is bigger than 3, so if we make more than 3 invalid results, then it should be a failure. And we do exactly the same thing for yes/no. So we generate a list of invalid yes/no answers followed by a valid one. And then we verify that if the number of invalid yes/no input is bigger than 3, it should be an error. So this way, this test really covers almost all possibilities. But as you can see, there are like various combinations. So potentially we may need to run it a lot before we find a counterexample. So that's why I added this extra parameter at the end, min successful. Because normally, by default, a Scala check use 10, if the test passed 10 times, then it's considered that the property is successful. So by adding this min successful 100 at the end, I say like, please be a bit more like, be a bit more careful. Try up to 100 attempts to be successful before you consider this property to be true. In summary, today we saw that it is relatively straightforward to implement error handling functions on I/O. This is because we have full control over when the action is evaluated. It only happens when we call unsafe run, and this is something that we can repeat as many times as required. Then, once we had these combinators, we could easily implement all the error handling logic inside user creation service. What's particularly nice is that the end result is very easy to understand. For example, I'm pretty sure that if we show the code of reducer to someone new to Scala, they will most likely understand what is going on. The most difficult part is to learn the for comprehension syntax, but as it is extremely common in Scala, we'll need to learn it anyway, even if we don't use I/O. Cool, so that's it for today. I propose to take a small break, and in the next video, we'll try to clean up the code of I/O. More specifically, we'll try to reduce the usage of unsafe run. See you soon.